Are you a coder who gets rejected based on no practical experience or because others have a strong LinkedIn personal brand and you don't? Your coaching institute will hate me for doing this, but I welcome you to Code to Career 30 days challenge where I have chosen these 5 total strangers out of my LinkedIn contacts and have taken up the challenge to help them go from jobless or underpaid to well paid job, that too without additional degrees and certifications in the next 30 days. If you are a coder and wants to get a well paid job, this is your golden chance to experience real project implementation from scratch that gets you a well paid job and builds your LinkedIn personal brand and also resume for absolutely free. So why just watch? Get into our WhatsApp community to experience this. Link is in the description. Now
Welcome to today's
let's
session.
get
Welcome to
started.
today's session where we are going to talk about some security aspects about TFTP and what extra optional acknowledgement you can send to increase. Let me start with a question. We said that we are having this optional acknowledgement because of which we are negotiating the data packet size.
Okay.
Now, do you think when we change or we take a decision like this, we need to back up with some statistics? How many of you agree that when we do some changes to code, you have to do a good amount of testing to validate that code? Even when you do test-driven development, you are starting with the test case and you are writing the code. But whenever a change has been done, you might be localized. You may be looking at a local piece saying that, okay, I have written something because I want to make this test case pass and move it to green. Can you guarantee that your changes are not going to affect the previously written code, which are written for previous test cases? Can you give any guarantee that it will not touch that? What is your answer? You can type
No
in the
guarantees.
type your answer. You can unmute an answer. Guys, you need to think.
See, if there is an independent module, then I don't think it should impact if we write it in a. It is
For
like
example,
let's take here only like uh, let's say here we are on the server side we are doing reading and writing. I mean,
yeah.
this both are getting handled. So I'm handling them as two different modules. So at any time only one will be executed. So in my sense, like what I'm trying to say is, if let's say I'm writing I'm writing a code for handle WRP, that should not directly or indirectly impact handle RRQ, for example.
Okay.
So in that sense, we don't. I mean, it's not always necessary that what we write should impact. It may, yeah, in the sense that it was like it should not impact if they are independent.
Okay. So individual functionalities, unless and otherwise we know that they are not being called, we don't have to worry. For example, let us say I'm converting, I wrote a function to take an average of certain ADC values. Yeah. So I don't have to worry that as long as I know the buffer is containing in the ADC values and I know how many values they are stored in a register or an array and I do summation plus division, I am good to go. I don't have to worry always that whenever I change some code, some part of the code, whenever I change some code, I don't have to test the average function. Functionality wise, yes, what you told is 100% correct. But what about pieces of code that depend on one another? What about the pieces of code that depend on one another? Do you think we need to test?
Yes, also like we need to do extension testing.
Okay, that is first part. Some testing has to be done to validate that our code, newly added code is not creating any problem. Now, the second biggest problem is not to get into a complacent mode, for the simple reason that now we are talking about a very trivial functionality, and hardly we may be looking at 800, 900 lines of code. But a production code for a particular product will span across minimum 20 files on an average. They will be much more than that. And so many people change so many things in the code, so many requirements. If the platform or the product has 2 or 3 variants, then many other changes in the same code base. The point I'm trying to drive home here is there is a lot of uncertainty with respect to our actions, because the uncertainty is creeping in for the lack of knowledge we have in a very comprehensive way. And this is where I was struggling in my career, and when I was in companies like Cisco and other things, there used to be somebody who is an expert for everything. And I used to wonder, see, what is this man? Can you ever reach their level? Can you even rub your shoulders? But what I understood over a period of time, yes, these people are experts. I have huge respect for them. There are handful of people, and I can count them on my fingers, not with both hands, with just one hand, who is expert in that area and also have a bigger understanding of what is happening as a whole package. When this device goes there, what happens and all those things. What I realized, these people, because of their nature of work of solving certain kind of issues, they get into they get into customer issues, and they understand different arrangements of their products, or where the environment in which their product is going, or different use cases, context, and they are building up their knowledge. So I thought either I should be in that project for long amount of time, even otherwise there is no guarantee that people will give you the work that you want. Even otherwise,
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the
in
description.
that work, if you don't get a credible bug or something which is not going to teach you, you are always in a zone wherein your learning is depending on a flip of a coin. I hope you people are able to understand what I am trying to say. There are no guarantees established saying that because you are in that company, because you are in that project, because you are working for that product, that your knowledge will increase. So I had to find a way to overcome this. So what did I do? And this is what is my strategy. I went and I have looked at all the bugs that have been solved by so many people last 5 years, 6 years, and all those things. I commented that code, I reproduced that bug, I added that code, I saw the test cases run, I saw the comments given, I saw the reviews. So that was some way of trying to reconstruct what has gone wrong and trying to gain knowledge. Making sense? How many of you are understanding this? There is a reason why I'm talking about this, and I will tie it up to this. How many of
I
you?
have I have a I have a question. So looking up all the bugs can get you the information about project, but it cannot give you the information about the architecture, like why was this thing made this way. So and from from the way you are explaining, it's way to look up all the tasks and understand them. But I don't you think that it is too much tedious to do, because it will take up a lot of time,
Yeah.
and yeah, it can and you can obviously and get some very, you can get some vague understanding but not concrete understanding, like why was this decision made here and there.
Yes. Absolutely right. It's so tedious. Each bug will take you a lot of time. You have to ration time from your work. You have to get that setup done, this and all those things. At least it is better than not doing anything. in the first cut. Apart from that, read the documentation, go and talk with people. Now, this is the catch. Not everybody is open to share knowledge. I want to be very clear. I know I'm on record, but I'm telling you, not everybody is open to share knowledge. People are protective of their knowledge for whatsoever reason, because of their insecurities. So this path did not yield bigger advantage of what I wanted to do. Getting the point? This is from the perspective of a developer to understand the code only, but not a system, what you'd call, what Kazi you called that architecture and all those things. Yes. So I flipped my strategy. I made friendship with my testers. I gave them a lot of importance and I started asking them like, how does this project really get used? What are the use cases? This, that, and all those things. There I got a bigger picture of a bug without going through the code. I read a lot of test cases. I understood this, that, and all those things. And apart from that, if you can get hold of people who can explain architecture of similar product, not the same, in any of your interactions on LinkedIn, that you form relationships and all those things, you can short circuit your growth by multiple years. And that is the reason why I was saying continuously from day one, you need to be there on LinkedIn, because when you have that network where people share knowledge, that you pick up, you hold it in your mind and apply it to your context. It may not fit, but it is possible to mold that understanding and fit to your context. And that can be only obtained from people. So what I'm trying to tell now is your focus should be not on the, it should be, obviously, it should be there with respect to the code and other things, but it should be more people driven in terms of understanding this. Because people have seen things grow and die in front of them with respect to the code, the changes, why that change has been done, and all those things. Ironically, most of the scenarios in many companies are, not scenarios, most of the issues with respect to code and many things are held in people's mind rather than in document form. So why is it I'm saying this? When things like RFC, which is supposed to be used by so many people, and when these kind of enhancements and optional stuff comes, people who propose this go back and do a validation of their enhancement. So for the enhancements that were done with respect to increasing the data packet size beyond 512, they have understood applying that change. And they also understood that with this enhancement is the backward compatibility still existing. So what they have done, they have taken the code with the optional acknowledgement change. They have put it on servers where the TFTP is still the older version and try to see whether it will work or not. That is what is there, right? That is what is the first thing to do. Your code is the latest one. Your client is the latest one, which is sending optional acknowledgement, but the server doesn't know anything. So it has to fail. You're getting my point? And the second aspect is you have to prove your thing, saying that because of these changes, there is definitely a reduction in the time delay. Throughput has increased and all those things. So people have done all those tests and they proved that these optional things actually work. And then this particular RFC, whatever is there, they were accepted. The point I'm saying is, by just looking at one document, you can reconstruct something in your mind which will help you when you are in a similar context tomorrow, in future, in your work. Because everything that is proven is in a document form, and they clearly wrote that this is the test we have done, this is the HP Unix we have run, this is what we have run, Solaris we have run, this is what is the throughput, this is what is the saving in the time, all those things. They also went and addressed corner cases. For example, let us say the data packet size has been negotiated, and it has been found that the data packet size, because the maximum transmission unit of Ethernet is 1500 bytes. And here TFTP is only just 512 bytes. So we have a lot of scope. So they went and they negotiated, and let us say 1200 bytes has been negotiated. Yeah. Now the client started sending, or the server started sending 1200 bytes. Now, when the last packet happens to be a multiple of 1200 byte. Now what we have understood is, a client understands that if the server understands that if the data packet is less than 512 bytes, it is the last packet, right? Remember? Now what if the data packet exactly falls at the boundary of the negotiated value? Because now the client has nothing to send, right? Now what should the server do? Are you getting what I am trying to tell? Are you there?
I
with
lost
me?
you at the end. I lost you at the end.
Sorry?
I lost you at the end about what you were explaining.
Okay.
Can you just repeat the ending part?
The optional data packet size has been negotiated, and it went to 1200 bytes. So client started sending. Server was giving acknowledgement with the packet number received, data packet number received, and client was happy. Client at the end had exactly 1200 bytes, and it has sent. Yeah. Now the server is thinking that if it is less than 1200, then I understand that, okay, it is the last packet, but it happened to be exactly 1200. So the server is now in a very confused state, right? Client has no data. Server has sent the acknowledgement saying that, okay, I have received packet 343 and it has sent. Now what should the client do? What do you think the client should do?
Client should at least there should be some way to notify that it's not closing the request. It has sent all the file.
What do you think it should be?
It can do that by sending a zero, just a zero.
This is the corner case, right? Not every data packet can be data file can be that it actually ends up in the multiple of 1200 bytes and the file is exhausted. So what they even address these kind of things, and they said that in case if it is falling at the boundary, the client will send an empty data packet with the header. So when I get an empty data packet, then I understand that this is the last, and I tear down the connection. So they went ahead and they also added optional.
We have faced so many similar issues.
Huh?
Yeah, sorry. So we have faced such. We have faced so many similar issues while we implemented the OTA routine for our microcontrollers. These corner cases and size of the file, we even didn't imagine like how many cases there can be in just simple file reading procedure, but there are.
Yeah. And all these headaches, application is nowhere concerned. The low-level software is nowhere concerned. Everything falls down on the protocol. So TFTP is also actually an application protocol, but I would say, let me say then the user is not concerned. Let me not say application is not concerned, but the user is not concerned. User just has a file and he or she wants to send. That's it. Making sense? Now these are the corner cases which have to be addressed, and they were addressed. The biggest problem with respect to TFTP always was that no security. right?
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
So this session, which is the last session, actually does not have much code, but more of this kind of theoretical understanding, which I will show you some boilerplate code and I will share the document also. But this is the time that you refer back your previous implementations and start adding something on top of the existing thing, which could be handling some different errors. So you add an error code. It could be something that you add an optional acknowledgement with a different field. Most of things are done, but as per your application, the use case, you can add those options also, because these people have added an extent these kind of optional acknowledgements, which will take care of not only the data packet size, not only the timeout, but also the transfer size. Now, what do I mean by transfer size? The client and server can also negotiate saying that this is the size of file that I want to send you. Possible? Even to that extent, optional parameters or options can be sent using this optional acknowledgement. Beyond this, anything you feel you can think as part of your use case, I strongly feel you should actually go and implement that. Implement as a smaller function, test it. I mean, write a test case. So think of a use case, think of a test case, what that use case should be in a positive, I mean, it should parts, write that, test it. The code will give certain it will return an error. So capture the error and try to see it does not get into that error condition. Few things can be invalid IP address, or you may want to stop more number of connection requests from the same IP address because somebody is trying to do something with your device. You can start imposing file permissions at the server side and try to see if I try to do something from a client in terms of writing into a file which is having only read permission, whether I am allowing it or not. There can be enhancements that are all possible from the server side to a very, very simple encryption kind of thing. I mean, very rudimentary encryption, or not allowing certain files to be accessed, or not allowing so many requests from the same IP address, or not allowing too many timeouts, or playing with a timeout which is different for different types of medium, Ethernet or Wi-Fi or something. These are all the options that you can try. The best way to try all these things, all these kind of things, is trying to imagine these functionalities being provided to you as libraries. For example, you have an encryption library, or you have a library which will not allow too many data packets coming from the same IP address. This is where the capability of you implementing this kind of code on Linux really shines, because you have something called as dynamic libraries, which you might loadable modules. You have modules, dynamic libraries, static libraries. These are the various features that differentiate Linux from other development environments. For example, C library. You can have a static C library or you can have a dynamic C library. Yes, in Linux also you have DLLs. Something similar is also there in Linux. So this is an opportunity for you to go beyond your traditional RFC compliant TFTP implementation to something that you really want to add and make it your own. because your application or your use case needed that. Now, what is that simple need? It could be that your server and your client, whatever it is, ultimately there is a file transfer. But under what context, with what guarantees, and with what kind of use cases that you want to deploy these two things will dictate a lot how you can modify and enhance the implementation, the basic implementation. Is this clear now? So that I will go and now show some cases which, and I will share this document in the group that you can go and work on them at later point of time. Almost implementation is done, but you can actually see it later. Any questions till now?
I have a question.
Yeah.
What is the difference between the dynamic link libraries that we have in Windows and the dynamic C libraries that you just mentioned? Is there something different?
I
Different in
really
them?
don't know how it operates on Windows, but in
Mhm.
Linux, I know that these are all dynamic libraries. You put it in the root file, you in the file system somewhere. Then you
Mhm.
have dynamic loader. There are APIs called DL_open and all those things. So dynamically, this loader will open the file and read only the part that it needs. It is not statically inserted into the code. Whenever it wants only, it go and reads that.
No,
So
understood.
it saves the space, especially in RAM, the RAM usage. Yeah. But Windows, yeah, I have never worked on Windows.
Mhm.
So first we will go through the document of today. The same problems that were mentioned, I will talk about the solution. Where is this? Hmm. This is here. Another document. Yeah. Is the screen visible?
Yes. Yes.
Okay. So basic implementation, we have part 6. Advanced timeout handling to improve the robustness. We have already done that. Some basic security measures. Now this advanced timeout handling is in the sense that we have an optional acknowledgement where the timeout value can be specified. But here it is based on certain kind of algorithm, which is round trip time. So the best way to understand, like I have sent a packet and I'm getting an acknowledgement. So by observing the distance between the time between two acknowledgements, I can figure out the thing. Because when I sent one packet from my side, until and unless I do not get an acknowledgement, I really do not know how far the packet has traveled, right? Because I start a timer here and I send the packet. I can stop the timer the moment I get the acknowledgement packet, the wall clock, which could be 2 seconds, 1.5 seconds. You're getting the point? So this is what is the round trip time. So the round trip time is me sending a packet like a WRQ or RRQ and getting an acknowledgement. Now, based on that, I can do so many things. I can actually set up my retransmission strategy. If I know this is the distance it has to travel, based on certain heuristics, I can actually get my maximum number of retransmission for a data packet before the server aborts the connection to prevent endless loops. Now, for example, implement exponential backoff in timeout interval to handle transient network congestion gracefully. Yeah. On the physical medium, many people might be actually using the medium. And this kind of exponential backoff, you will also hear when you read about carrier sends multiple access with collision detection. Two devices on the cable on the network send at the same time, the packets collide. And I would say actually you have to really read Computer Networks by Tenenbaum, and it explains very clearly how does a station actually come to know that the packet has collided, because it has to still observe the physical line saying that did I get back certain pulses back, some reflection is there, many things happen. So what when there is a like at time t1 both.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
Both the stations have sent the packets, so there is a collision. So when both stations will now detect that there is a collision, then one of them will roll back for certain amount of time based on this exponential backup. So that, and it's a random function, so that it will never happen that again these two stations will start sending at time t2. If station sends at time, station 2 sends at time t2, station 1 will send at time t2 plus or minus certain amount of time. This will be a intellectually very gratifying adventure if you can read about it. Now, security measures. Yeah, we already know there is no basic security. So read write permission, which we already discussed. Rate limiting, we discussed. Logging and monitoring. Who logged at what time? What are all the requests? At what time write request went, at what time? All those logs and things, monitoring for auditing and looking at the code. We have implemented only timeout and retransmission server code. The classical question, why did we put again adjust timeout at the front? I am intentionally asking this question. The answer is obvious. What is the obvious answer?
TDD.
Yeah, I want to nail TDD into your mind. Before you even write a code, write the test case, let it fail, then make it pass, so that you are confined in a zone where you are not writing too much of code, always assuming what you want to solve. You start with what you want to solve, but what happens in that thing of I want to solve this, we tend to write code which we don't have any control. So you write certain amount of code you feel which is sufficient to solve this problem, immediately go and test. The test case becomes green, stop there. We will see if any other test case fails, then come back and write. But यहाँ तक तो एक टेस्ट केस जो आपने सोचा पास होना है वो हो गया, तो you can stop coding. That's why TDD is so important. So we have to adjust the timeout depending on our retransmission strategy. Yeah, timeout and retransmission strategy. Based on that, we have to adjust the timeout. Now, timeout is an optional thing. So somewhere there should be optional stuff here. Okay, initial timeout 2 seconds. Okay, it is only for timeout implementation. That's why we are adjusting the timeout. Return base timeout is equal plus return base timeout. So you start with a certain basic timeout plus round trip delay into 0.5 is to simply randomize that. See, there is nothing so specific or so special about 0.5. It is only to randomize that round trip time. And at least, in fact, take half of it. Main function is clear. This is clear. Bind failed. Socket, size, buffer. Yes. Now I am starting the wall clock. Initial timeout. And I am setting the socket options. So this is one API I want you to go and look. We have discussed at some point of time, I do not remember which session, that you can actually set some options to socket. And you can imagine that there is a big socket function, and certain aspects of that socket functionality are decided by a very large switch case. So all these options, you can assume that they fall into one of these switch cases. So we set the socket options and then we start receiving. Where is this? Yeah, here process packet. Now, where is this adjust timeout? Oh, it is missed. I have to look at the code where packet process receive timeout or failed. Okay, receive timeout. So let me get back about this code. Not sure if I have copied the wrong code or we have to calculate and we have to give this thing, adjust timeout. We set the socket options. Then when that does not happen, we have to go and call this function to set the new timeout. This is the place where we are setting the timeout. We will reset the timeout again after calculating. So I will look at this code. Something got goofed up here, but let me look at this code and get back to you. Any questions so far about this? Forgetting the code. Is the concept clear? Any questions here? Chiranjeev, Kazi, Harshavardhan.
So yes, so the set stock of that is like it is similar to what select is doing, or it's separate, totally separate thing.
These dictate the behavior of the socket. It has nothing to do with select system call and all those things.
Okay.
Yeah. These are the internal modifications of the socket. Select
Okay.
system call is for you for that single thread, for that single process. Yeah. Okay. Now let me share another thing. So the problems that we have discussed, I have a small implementation. And this implementation was not tested. Where is that? Yes. So we start dynamic timeout adjustment. The algorithm is very simple. Start with a base timeout. Adjust the timeout based on the observed round trip delay for acknowledgement packets. Initialize the base timeout. Calculate the average RTT. Adjust the timeout. New timeout. Base timeout plus average RTT into 2. So this is the code segment. So I will share it to you. I think this is correct because I did not test. I have a little bit of concern with this code. Maybe this code is actually taking care of the adjusted timeout only. Yeah, that's the thing. So basically what has happened is already set this code, that code is correct. That code is actually setting the adjusted timeout value in the socket options. So it's not that something has happened. I am initially starting the server only with, because I know the round trip delay, I am adjusting the timeout value because it falls into my strategy of retransmission. So that is about this retransmission code. The second thing is retransmission, that is a timeout strategy, and this is the retransmission strategy. We define the maximum number of retransmissions and we implement the exponential backoff to handle transient congestion. So both are different. In the first case, I am only worried about the timeout value that I want to put in my socket. And the second thing is, if there are collisions and if I have to retransmission because there is something wrong with the medium on which I am transmitting my message, I, as an entity on the bus, what decision should I take? Do I have to wait for some time? Yes, I have to wait for some time. But how long? That is a retransmission strategy. So I want you to understand the difference between both. One is a timeout, which is what I am calculating based on my acknowledgement, my data sending and reception. The other thing is retransmission because something has happened with the packet that I have sent. but got collided or whatever because of the medium, that I decided that I will transmit after some time. Both are two different decisions. Any questions here before I show the code? Because these are a little bit conceptually heavy. Okay, so let's go and look at this code. Max retries. Handle packet is same. So we are using the max retries with the same timeout again. The timeout value that we have set, same timeout means the timeout value that we have set. And we are increasing the retries.
So sorry to interrupt.
Yeah.
So can we understand this like in the previous code you had mentioned the like attempts, right? Number of attempts. We kept it in a loop within that while loop. So is it like similar? I mean, is the set sock of doing the same thing?
Yes, both are same.
Okay.
Both are same. Okay, this is similar to that only. So there is no much different. Retransmission is no much difference. Exponential backup is not there in this code. Now read-write permissions are very simple. You define the directory that you have and you see what is the directory name that that person has sent, and you are taking the action based on that. As I mentioned, this is not a complete code. I'm just trying to give you a boilerplate code that you can test on your own. The read-write permission for the file that or the location that you have created, and checking whether the path has been correct or not that was given to you. Then you are handling the read-write operation. Yeah. This is only with respect to the path, not much more. Now rate limit is,
if you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
trying to stop some client sending too many requests. Now, why you have to rate limit, or how does it impact? Understand that for every kind of operation that I trigger, a separate TID gets created. Remember? So rate limiting is in one way allowing the overconsumption of TIDs. So I just see whether I am getting, see so many clients, example up to 100 clients. And I check here somewhere the number of IP addresses. Yeah. So if I'm getting so many from this address, I will rate limit. And logging and monitoring is very easy. You create a file and you keep on logging every information into that with timestamp and everything. Simple implementations. But if you start implementing, you're writing more code around this, you will have a very robust TFTP server coming out. But this templatized code can become your starting point, and I will share it in this group. Yes, today's session is not much into the code, only to give you a direction that from the basic TFTP implementation, depending on the kind of application that you want to do. Now, in our case, we have started with an SM2 application that we want to do firmware upgrade. When you start thinking about the firmware upgrade, traveling on different kind of physical layer, then you may want to add so much of protection around it, because ultimately it is your firmware. If it is on Wi-Fi, then you may want to do some kind of encryption. If it is on physical medium which is closely guarded or something, then you may not have to worry about encryption, but still you want to ensure that something can be added, whatever. And this exponential backoff and retransmission, they become more and more prominent when you are going for medium like wireless. Now here is the thing. Normally what happens, if you recollect whatever I was telling earlier, that each layer of the stack had its own responsibilities. It is not absolutely necessary that whatever we are discussing now have to be the responsibility of your TFTP only. Maybe the file permissions you may have to take care, because you are hosting the TFTP server and you have the files. But the exponential backoff and rate limiting of something, it can be delegated to some other layers also, especially the random backoff or exponential backoff. But remember one thing. This is all with the assumption that you have a well-built and established protocol stack for you, on top of which you are running the TFTP. What if you do it on an RTOS where you don't have the privilege to put a complete TCP stack or something, where you need to tailor your TFTP protocol in such a way that you may not have to worry about WRQ at all, only read or vice versa, but add some kind of security mechanism around it. Then these kind of activities become very important. You want to do a bare metal stuff or on some kind of platform. That's why the whole idea of the project is on Linux, anyways, you can run it. But what if you want to port it onto your own platform? Even if you have 80 mega 2560, you can do it. You have LPC 2148, you can write this code and port it and see how it behaves. Interface a little bit, some device which has TCP IP stack, give your TFTP packet to that. It has its own hardened. There are controllers actually that are network controllers or some devices. I know only the Ethernet thing like ENC28J60 kind of thing, which is 802, which is the Ethernet chip. But there are some devices in which a permanent TCP IP stack is burnt into it. You just have to give certain data to it and it knows how to send it outside. Like all these Wi-Fi chips, right? You don't really worry about Wi-Fi chip. You just send, this is my data, and the Wi-Fi chip automatically does for you. Same for Bluetooth. In the same way, the other things also can be done. That becomes your embedded Linux part. Clear? Any questions? So you have a wider scope now. You have a complete protocol implementation. You have seen the various ways it can be used. If on Linux, how the effort will be less or more. And if it is something that I have to do on my own, how much effort is needed, or how much effort that I can give it to someone and then do minimal thing from my side. So the next two sessions are more or less will be theoretical because there will not be any code. This session itself, we have seen that there isn't any big code because it's all done. The TFTP proper has been done. TFTP server proper has been done long time back, but we went ahead with all the other extensions and optional things. Now, these are all the things that some other layer can do, but what if I have to do on my own kind of scenarios? Any questions? Okay, no questions.
This is one of the sessions that I would like to watch again, to just note down the concepts and think about them in detail, to cater all of the cases, because it was rather a theoretical one. So
Yeah.
just to get the clear concept, then I can have, if I have any questions, I will definitely.
If you Want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.
Share it on
Yeah,
Monday.
I will share it tomorrow morning. Yeah. Okay.
Hey,
So
Vamsi, I
any
have one
other
question.
question? Yes, yes. Yes, Swaminathan, go
Uh,
ahead.
so Vamsi, so when you say portable, right? Like we generally, what I understand is like, okay, the code I must be able to as much as possible reuse it in any different platform. So that will make it reusability. So
Hmm.
when I am trying to do, let's say on Linux, okay, that's fine. Let's say it has a networking support, all those stacks are there, that's fine. So
Hmm.
when I say portable, it's like on similar platforms, right? Like where similar support is there. If I want to move towards, let's say, bare metal, then that will be a totally different platform. I have to write everything from scratch, right?
Why do you want to write everything from scratch? Okay, what is that you want to write from scratch? There are
So
some
if,
things
let's say
there are there, but I want to understand from your perspective.
so from even let's say in this case, let's say I'm trying to port it, I'm using UART as a physical medium,
Ah,
and on top of that I'm building TFTP. So
ah,
basically I just have two layers. That is file layer, which is the protocol. I can use it the hall layer,
hmm,
HAL. Then on top of that I'm using my TFTP. So
hmm.
there, let's say the arguments etc. It won't be it need not be the same, right? I mean let's say I need to change the function arguments accordingly, etc. Right? I mean it should not be the same. So
Ah,
it's in that case portability will be a problem, right?
yeah. Very, very good question. Actually, very, very appropriate question, and I appreciate you asking this question. So typically in these kind of scenarios, let us say you wrote your TFTP implementation and you prove it to be working for various cases, address the corner cases also, and every implementation is done. You have a good code. Now you want to put it on one platform where suddenly the physical medium changes from UART to I2C, right? This is what is porting. For the first time when you are writing, there is nothing like porting. You are implementing. The porting thing comes that something changes, the underlying stuff changes, and the controller changes or something changes. So typically, what happens in these kind of scenarios, you will write a glue logic which gets sandwiched between your so-called that you told the physical layer, right? Between the physical layer and your TFTP implementation, which will translate the TFTP APIs, what it wants to understand, into the kind of APIs that your physical layer wants to understand. So you don't have to change your physical layer code also, which means your driver and all those things. You don't have to change TFTP also. You just have to say that, okay, in the final stage of TFTP, when it is saying send, you say handle RRQ. Now handle RRQ after its housekeeping and every operation is done, it will call your sandwich layer function, which will take, it knows what each part of the protocol packet or whatever it contains, and then it will put it in another buffer or something what the driver layer expects to be in. So most of the code you see will be of this kind of glue logic. So most of the porting work will be like this, because it is practically impossible for everyone to sit and write everything from scratch. And when there are things that are already proven, nobody wants to touch them actually. And they say, right, don't touch it if it ain't broken or something. When something is working, don't touch it. So people write this glue logic and all those things. And this is where, even for testing also, for testing purposes and all those things, this is where you actually hear, how many of you heard this term called as stub, STUB?
Yep.
You test stubs and all those things they say, right?
Yeah. Yeah.
Yeah, these are all those kind of mock functions.
Mock functions.
Yes, these are
They're,
like that
yeah,
mock
they're
functions and all
fakes
those
as
things.
well, spies.
Yeah. So typically what happens in certain in certain scenarios, you have your code which may not be addressing all the requests from everyone, but people will be calling those functions. So what you say is, acha, I don't want to stop you from, I don't want to change you, or I don't want to restrict you from not calling that function. You call blindly, I will return true. So you write a stub function or a mock function. Yes. So these are all other mechanisms. So any other questions? How has been the experience with TFTP? Vamsi, you brought us to somewhere and you left us in the middle of some forest. See, I will anyways have your feedback one-on-one and all those things. I will be setting up some calls. But otherwise, okay,
So
it's
for me at
great.
least, like TFTP was a good start. I mean, I felt like I don't have a reference, so it felt like a kind of it resonated. I mean, okay, let's start with TFTP. Maybe the mindset was like that, or the protocol itself is simple. A lot of things, but I would say it started on the right note with TFTP.
Okay. Yeah, intentionally it was, as I told, it was made to be very small to do that. So the next two sessions, we will go through that service-oriented architecture, which is one of the concepts that gets heavily used in adaptive AutoSAR. And you will also see a lot of similarity between publisher, subscriber, and all those terms that people hear, right? So you will see that actually being used. And finally, making this particular code, take it, convert it into a library or port it into an ARM controller, onto an ARM controller. Yeah. LPC 2148 board, you will get it a lesser price and you have good tool chain support also. So you can actually do it. And it has good number of interfaces. Then you can graduate to actually porting it on Linux.
We can do it on Pi also, right? Pi with let's say Linux we have the Scali or something.
Uh, are you talking about Raspberry Pi?
Yeah.
Yeah, obviously. Yes. You should. I haven't much used Raspberry Pi. Used Big and Bone Black once, but after that, yeah, in our office they got Raspberry Pi, but I did not use it so much because I was busy with my other bare metal stuff only. So let me ask who is there today. So Chandrika, any questions from your side? Your voice is breaking.
Yeah, Vamsi, am I audible now?
Yeah, you are audible now. Yes, please go ahead.
Yeah, not now. Maybe on Monday. Last I started in the morning, so forget I'll ask you.
Sure. Because the other two sessions will not be anything related to code. That's why I want to just sort out anything today. So the remaining two sessions would be more of a theoretical. It's oriented highly towards theory and other things.
Okay.
Yeah. So Harsha, any questions from your side? Harsha, are you there? Okay. No issue. Chiranjeevi, any question from your side?
No, see, I'm in the feel of like mixed emotions actually. Everything is like, yeah, I don't know, yeah, what to ask. See, yeah, I'm learning the fundamentals, and then I'm referring your materials actually.
Chiranjeevi,
So,
what is, don't feel emotional. You are not proposing to me.
no, see, like mixed emotions in the sense
It's
like,
pure technical. Understand, implement.
yeah, Vamsi. No, like the thing is like, yeah, understanding, and then I'm thinking myself, which whether my understanding is right or not. So I need to have side references and all side references material to understand what I'm doing is right or not. So that kind
Mm.
of thinking I'm having actually. But but it will take some time. When frankly speaking, I will extend still 15 days to understand what has gone through this TFTP actually. Yeah, I'm just implementing, reading code line by line. I'm started implementing actually. I'm reading code line by line, and then yeah,
See, these are all
modifying
the
the stuff.
these are all internal conversations and all those things. They are natural. Okay. You don't restrain them, accept them. You can actually adopt this technique called Feynman technique. So the best way is that when you try to explain to someone, you make yourself more clear. Otherwise, you will have this internal struggle only. And you are not, when you are not able to articulate, you will feel that, okay, man, I'm hopeless. Man, so much so that I had this worst feeling of my life when I was preparing for IITs. And worst feeling. Like I felt I am an untouchable because I don't understand this concept. And these people, they were all discussing about it, that capacitance, this thing. I don't know what is happening with me. Horrible. You used to be very afraid to get into even those circle also. Dreams of people laughing at me, getting humiliated, what not. So this is normal. So the day I started telling to myself, so one of my mentors at that point of time, actually he's my relative, but he's a motivational speaker. So he told, Vamsi, if it is becoming very difficult for you to explain anything to you are not able to catch hold of anyone and explain anything. So what he actually gifted me a teddy bear. And he told, okay, this is my gift to you. So I told, boss, this is not Valentine's Day. And I don't understand what is that teddy bear that you have given to me. So he told, you learn a concept, explain to this teddy bear. And those were the times when these phones with speaker and this audio recorder used to come. So you explain to this teddy bear, and then you listen back. And this helped me a lot. This helped me a lot, and it made me feel that, okay, if I can understand something so good and I'm able to explain, maybe I should really try these kind of things. So Chiranjeevi, this is what I adopted, and it helped me a lot. I hope it will help you also.
Yeah, no, this.
How many of you
I'll go and
find
get a
this?
teddy bear.
How many of you
Yeah.
are getting a feeling that this will help you really? Type me in the chat box. This method of telling to somebody, teaching to somebody. If there is no one, just put a doll in front of you. Yeah, Chandrika can actually tell to her daughter or son, I think.
Yeah. Sometimes she'll listen to your class also.
Yeah. Yes.
We
You
both.
tell her for anything, she will say yes, 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 yes.
Yeah.
Great. So let us meet again on Monday. Saturday I will try. If Saturday, if it is not possible, that is tomorrow, if it's not possible, then Tuesday we will have a session on adaptive AutoSAR. Yeah. Clear? Okay then. If there are no questions, I think we are good to go. Bye. I will upload the video tomorrow.
Thank you.
Yeah. Thank you. Bye.
Thank you, bye.